We want to solve quadratic functions by graphing and factoring, and we want to use factoring to find the roots to the given equation. So here we know that this is a quadratic function because we have x squared or we have the variable squared. So anytime we have the variable squared, we know that we have to have one side of the equation equal to 0. So at that point, we're ready to solve, and in this case, we want to solve by factoring. So the first thing we want to see is, do we have any common factors between 4, 17, and 15? And in this case, we don't. So the next thing we have to do is we have to come up with what the factors will be. So we're going to try to get it to a binomial, and we can think about what numbers could multiply to 15, and that can be 1 times 15, or it could be 3 times 5. And then we got to think about what numbers could multiply to 4 times 1, and 2 times 2. So we know that in our first binomial, we're either going to have 4 and 1 or 2 and 2. And then in our last, we're going to have 15 and 1 or 3 and 5 in some capacity. Well, 1 times 15 will get me here, but then if I say like 2 times 15, that'll get it to 30. So, or 4 times 15, that's not going to get us to 17. So I'm probably not going to use this. So I'm going to skip 1 and 5, and I'm just going to go to 5 and 3. And I know that I have to get to 17. So if I picked 2 and 2, 3 times 2 is 6, and 2 times 5 is 10. If I add these two together, that only gets me to 16. That doesn't get me to 17. And so pretty sure that it's not going to be 2 and 2. So then I'm going to try 4 and 1. If I put 4 here, 4 times 3 is 12, and 5 times 1 is 5, so that might work. But that won't work because one of these has to be positive and one of these have to be negative, so they won't be able to add together. So then what we have to do is we have to use the 4 and the 1, and we have to use the 5 and the 3. And we have to multiply to negative 15 and add to negative 17. So the 5 has to be negative and the 3 has to be positive. So we have 4x plus 3 multiplied by x minus 5. So at this point, we can use the zero product property. And we can set each equal to 0. So then we get 4x plus 3 equals 0. And then we can get x minus 5 is equal to 0. So here we add 5 to both sides. And we get x is equal to 5. And here we're going to subtract 3. And then we're going to divide by 4. So our two zeros are x equals negative 3/4 and x equals 5. So in this case, we have a multiplicity of 1. Because each zero represents one solution, or each answer represents 1 0. Next thing we look at is b. We have 3y squared plus 22y plus 60 equals negative 14y minus 48. And the difference between these two is b does not have one side of the equation equal to 0. One thing that also helps us out is if we keep the coefficient in front of the square term positive. So I could move these three terms over here, but then I'll have a negative 3y squared. So I want to move these over to the other side. So the inverse operation, these are both subtraction. The inverse operation of subtraction is addition. So I'm going to add the constant to the constant, and I'm going to add the y term to the y term. So what we get when we add those together is we get 3y squared plus 36y plus 108. And that is equal to 0. So we can start to solve or start to factor. In this case, I know that all three of these are divisible by 3, so I can factor a 3 out. So 3 divided by 3 is 1, so we're just left with y squared. 36 divided by 3 is 12, so 12y. And 108 divided by 3 is 36. Now I can factor this in two numbers that multiply to 36 and add to 12. That is going to be 6. The only two numbers that are going to multiply to y squared have to be y and y. And then to get to 36 and add to 12, we pick 6 and 6. And in that case, they're both going to be addition. So y plus 6, y plus 6, still equal to 0. And then we understand that y plus 6 and y plus 6 can be rewritten as 3 times y plus 6 squared. And then we can get that equal, then we can solve that for the zero product property. So the only thing that we really have to set equal to 0 is what's inside the parentheses. So we can subtract 6, and then we get y equals negative 6. And for this one, we have a multiplicity of 2.